Hello, welcome again. This is going to be the workshop number 7. First of all, we're going to create a new database. We're going to name it tension feeding. We click OK, and we're going to choose base and model and click OK. Now we go to geometry. We go to create. We go to surface, XYZ, XYZ. For the vector coordinate list, we are going to enter the values of 5, 2, and 0. We're going to turn on auto execute, and our coordinates 0, 0, 0. Then we click apply. Now a surface is created. Now we go to transform, point, translate. On the vector direction vector, we are going to introduce 0.500. For translation vector, we're going to select on point list, we're going to select this point. We click apply. Now this point is created. Then we repeat, but we are going to change this, and it's going to be 0 and 0.5 in Y. On the point list, we are going to erase it, and we are going to select this point right here and click apply. Now another point has been created right here. Now we go to create curve point, option 2 points. Starting point is going to be this, and ending point is going to be this one. Then we click, well, it was already an auto execute, it already applied. Now we're going to break the surface to lay the upper piece. We go to edit, we go to surface and break. Not auto execute, we select surface 1 and curve this one, then we select apply. I click yes. Now we are going to delete the upper part. We are going to delete, then we are going to surface. Now first I click on refresh. Now delete surface, select surface. This is surface number 3. Select apply. Now it is deleted. Now we go to create. Here we go to solid. Now we go to extrude. Now we turn off auto execute. We make sure we have selected that depth measurable, and we're going on the translation of vector. We're going to put 0, 0, 2. Surface, we select surface 2, then apply. Now this is applied. Now we go to ISO 1 and smooth. Now we see how the solid it is made. Now we are going to create a shell. We go to create. Well, we go to edit, then go to solid. We're going to shell. Thickness is going to be 0.25. we turn off auto execute and we select the faces. Well, here, select this, and this one. We select all those front faces and click apply. Now we're going to do some fillets. We action edit object as solid method as edge blend. We choose constant radius. The parameter radius is 0.5. Edge to blend is going to be edge of solid. We turn up auto execute. Then we're going to choose the list of lines that we are going to make. Then we click apply. Now there it is, the solid already with the fillets. Now we go to create solid primitive. We are going to select the cylinder figure. We are going to height, we're going to put 2. The radius, it's going to be 0.25. Thickness is going to be 0. Coordinate, we will 0.1. Auto execute, we turn it off. We're going to put the values, and it's going to be -1, 1.25, and 1. Then we hit apply. We go to edit, solid. Now we are going to boolean. We are going to subtract. On target solid, we are going to select the cylinder, and the target solid is going to be this, and the subtracting solid is going to be the cylinder. Now we hit apply. Now it is. Now we click on the wireframe. Now we see all the points and dots. Now we are going to geometry, transform, point, and translate. We're going for the translation vector. It's going to be 0, 0, 0.5, minus 0.5, and we're going to select 0.30 and click apply. Now we have the new point. Now we're going to enter to the vector here a new set of coordinates that are going to be minus 0.75, 0, 0, then we hit apply. Now we have the new point. Now we change again the direction vector to minus 1.5, 0, 0. We are going to repeat this 2 times, and we are going to select the last point, that is point 36, and select apply. Now we have the rest of the points. Now we create solid primitive, the cylinder figure -1 on height list, minus 0.125 on radius. Now on chord we're going to put 0.2, and base center point list are going to be the last 3 points we made, this, and this one. We're going to hit apply. Now there it is. Now we go to edit solid boolean. We choose this figure, target solid as solid 1, and subtracted solid are going to be the 3 cylinders, this, and this one. And we click apply. Now I have the 3 holes ready. So to create point arc center curve list, we're going to select this one and click apply. Now I create a point in the center of the circle. Now we go to create solid primitive. We point 0.1 for height, 371 for radius, and here on point base we're going to choose this one and click apply. Now we go to the smooth shaded and we have the cylinder in the middle. We go to edit solid imprint. Solid 1 is going to solid list, solid imprint list is going to be solid 2, the cylinder, then we click apply. We're going to delete the solid, we go to delete, solid list, we're going to select the solid number 2, we click apply, then we hit refresh, now the solid is gone. Now we're going to mesh, we go to create, mesh, we're going to choose solid, that mesh 10, input list. On the input list we put alt solid 1, automatic calculation, then we click apply. Now here it is. We go to load and boundary conditions. We create total load, element uniform. We create a set new name force, input data minus 5000, 00. Click OK. Select application region. We're going to select this one. We click add, OK, and apply. Now we have the force applied. Now we create displacement nodal. Then we are going to name fixed. Input data is going to be 000. OK. Application region, it's going to be these 3 holes. OK. Now we click on apply. We're going to create a material, isotropic. We call it aluminum. Input properties 10E6, 0.3 on Poisson's radio. Then we click apply. Now we created the material. Now create 3D solid. We name 3D text. Now input properties, we're going to select aluminum. Click OK. Now select application region. We're going to select everything. Add, OK, then apply. Now we apply it to the entire. We're going to run the analysis. Entire model, full run, solution type linear static. OK, sequence 101. We run it. We attach the results. To results, attach transnational displacements, apply. Now we see it. Thanks for watching.